Here we are. We're looking at the normal approximation of the binomial distribution. We said a ways back that the empirical rule can be used if you have a binomial random variable as long as np times 1 minus p is at least 10. The empirical rule is derived from the normal distribution. So in reality, what we're saying is that we could use z-scores and normal tables to estimate binomial probabilities. So let's consider a binomial when n is 40 and p is 0.45. Well, okay, if we do that, then n is 40 times 0.45. There that is 18. And 40 times 1 minus p, oh, sorry, let's do the whole thing. Clear. 40 times 0.45 times 0.55. That's this n, p, 1 minus p. 40 is n, p is 0.45. So 40 times 0.45 times 0.55. Okay, hit that. So that's 9.9. That's pretty close to 10. So we're going to take 9.9 as being close enough to 10. And there it is. Binomial, n is 40, p is 0.45. We did a huge number of trials, made a histogram. It's very reflective of the shape of a binomial distribution. All right, so let's compute the approximate answer using the normal distribution for probability x is 16. That would be the area over 16. So here's where 16 is here. So that means from this side, it's 15.5. And on this side, it's 16.5. So we're going to compute the area between 15.5 and 16.5 under a normal curve whose mean and standard deviation will be the mean and standard deviation of that binomial distribution. So let's go ahead and do that. So it's on the next page. Here we go. So it says here, n is 40 and p is 0.45. So mu is m times p. So 40 times 0.45 is 18. Okay. That's what I was trying to type before. I got carried away. And then we're going to take the square root. So let's do that. Second square root. Where is it here? Okay. Then we 40 times 0.45 times 0.55. That's n times p times 1 minus p. I'll go over 1. Hit enter. 3.1464. 3.1464. I just kept a lot more places than I actually need, but I always do that just to be safe. And then we compute z for 15.5. So z is x minus mu over sigma. X is 15.5. Mu is 18. And the sigma is 3.1464, like that. So we'll go ahead and type that in. I use parentheses for the top. 15.5 minus 18, parentheses, divided by 3.1464. All right. Now we're looking at 15.5. It's down here. It's below the mean. So when I compute the number of standard deviations away from the mean, I expect a negative answer. Off we go. Negative 0.79. Negative 0.7945. And then we do the same thing for 16.5. Z is 16.5 minus 18 over 3.1464. I'm going to use a trick. Second enter. Retypes that thing I just made. That's nice. And all I have to do is change this 5 to a 6. So I scroll over there, make it a 6. Hit enter. Minus 0.4767. Minus 0.4767. All right. And then, oh heavens, I need normal tables. I know I printed them, but oh, maybe they're down here. They might work. Got all kinds of tables. Will these work? They might. This looks like the right thing. have a bunch of tables, but none of them are the right ones. Well, okay, we'll go to the book. There we go. I'm in the back of the book looking for the normal tables. Oh, there they are. And we have those negative numbers. Here's the normal tables. Let me get this slid over a little bit so we can put them in there. Heavens, there we go. So now we're looking for in the tables of the two numbers in question. Having difficulties here. So we go, for negative 0.79 and for negative 0.48. Well, they get two places in the tables. Okay. 0.7, there's 0.7. And they'll come over here to 9. So that's all the way at the end. 0.79. You with me? The third one down is 0.7. Up here, we have the 9 for the goes with the 0.79. 0.79. 2148. So that's the proportion below negative 0.79. And negative 0.48, there's 0.4. And over here to 8. Okay, 0.3156. Okay, we did that. And then, to find the area of this bar, so what are we doing? We're attempting to find the area of this bar here. And what we're saying is we can use a normal curve that approximates the distribution like this. And then we find the area under the curve instead of the area of that rectangle. So it'll be close, but it won't be exact. I didn't draw that too well. Usually it goes almost right through the middle here. Oh, I'm making it worse. Well, there we go. I made it worse. It's a pen. I can't undo it. So to find that area, we'll take this area back on this side. Do I have something better to do this with? Let's see. Some red. We're going to take this area here. That's the little area. And then we'll take this big area here. We'll take the big area minus the little area to get the area of the skinny little bar right here. So we'll take 0.3156 and subtract off 0.2148. Okay, let's try that out. 0.3156 minus 0.2148. So I get 0.1008. So that's the approximate area. I used the formula to get the exact area, and I got 0.1, where is it? You can't see it. 0.10433. Let's go ahead and do it right here, though, just for grins, since we're here. The actual answer, it's n cx p to the x, 1 minus p n minus x. That's the formula we used for a binomial. N is 40, x is 16, p is 0.45 to the 16th, and then 0.55, 40, this is 40 minus 16, which is 24. 24 plus 16 is 40. That's right, like that. And I'll know in a minute because I'm supposed to get 0.1043. Here it comes. So how do we make this start over? Okay, here's how do we make this. We type 40, type math, we go over to prob, and then we pick NCR, and then we put the 16 in. We come over and we go times. And then go 0.45. The up arrow here, where's my finger? The up arrow there makes an exponent. Get up there. The exponent is supposed to be 16. And I come over again, I put times. And then 0.55 up arrow, 24. And I come over. So with any luck, I'm going to come up with the 104. Let's see what happens. There it is, 10433. Happy days. Everything worked out okay. Okay, so 0.10433. Okay, so that's an example of using a normal curve to estimate binomial probabilities. And we can even do the probability of a single value like we did here, the chance of getting 16 by taking the area of a single bar, which extends 1/2 a unit on each side of 16. So from 15.5 to 16.5, since each of these bars is over each of the numbers that are possible. The one before that is 15, 14, 13, 12, and so on. So this individual bars are width 1, and that means you have to go plus or minus 1/2 to capture a value. We'll be seeing that idea in a minute when we try to do other calculations, but that gets us started. And I'll see you back in a minute because I'm going to stop recording now and get ready for the next little bit.